Hello and hi everyone, we are from Group 3. Today, we want to present about oxidation. Oxidation, it can be defined in terms of adding oxygen in a compound. Oxidation involves an increase in the oxidation state. Other than that, you can also remember by Leo, loss of electron is oxidation. Next, you can also recognize by change in the oxidation number. In example, if I have the ion Fe2+ reacting to form Fe3+, you can easily learn that when the oxidation number or charge goes up or being oxidized, there is oxidation. List of common oxidizing agents. We have two types of oxidizing agents which are strong and mild oxidizing agents. The example of strong oxidizing agents are potassium permanganate, hydrogen peroxide, potassium dichromate, chromic acid, and many more. The example of mild oxidizing agents are pyridinium chlorochromate, silver oxide that used in Tolan test, Martin pyridinane or DMP, and many more.
Oxidation reaction by various types of oxidizing agents. We will start with strong oxidizing agents. Potassium permanganate. It can oxidize aldehyde to carboxylic acid. For example, benzaldehyde reacts with potassium permanganate to form benzoic acid. Hydrogen peroxide also can be used as a strong oxidizing agent. It is used in ozonolysis to oxidize ethanol to ethanoic acid. Potassium dichromate. It can oxidize primary alcohol to carboxylic acid. For example, 1-butanol is oxidized by potassium dichromate to form butanoic acid. Lastly, chromic acid can be used to oxidize secondary alcohol to ketone. For example, chromic acid can oxidize cyclohexanol to cyclohexanone. Oxidation reaction by using mild oxidizing agent. Pyridinium chlorochromate. It will oxidize primary alcohol to form aldehyde. For example, 1-butanol is oxidized by pyridinium chlorochromate forming butanol. Silver oxide. It can oxidize aldehyde to carboxylic acid. For example, silver oxide oxidizes hexanol to form hexanoic acid.
Next, we're going to look at the oxidation of different types of compound with their respective example. We will be looking at the oxidation of two types of compounds which are alcohol and aldehyde. To determine the product of oxidizing the alcohol, we need to first figure out if the alcohol is primary, secondary, or tertiary. How? By looking at the carbon that has the hydroxy group on it. If the hydroxy group attached to a primary carbon, it is a primary alcohol. If the hydroxy group is attached to a secondary carbon, it is a secondary alcohol. And if the hydroxy group is attached to a tertiary carbon, it is a tertiary alcohol. Let's look at the primary alcohol. Remember earlier in the video, oxidizing is adding the oxygen and removing the hydrogens. Now look here. In primary alcohol, the carbon is attached to a hydroxy group and two hydrogens. On the first oxidation, we can remove the hydrogen in the hydroxy group and the one attached to the carbon, resulting in double bond between the carbon and oxygen. Remember this structure? Yes, it is an aldehyde. So, oxidation of primary alcohol can give us aldehyde. The example of the reaction is as follows. As you can see, pentanol is oxidized to pentanol. Because we still have the hydrogen attached, we can further oxidize it, but we no longer have a hydrogen on the oxygen that we can remove. So we're going to add a second oxygen to the carbon with the hydrogen. This gives us a carboxylic acid. So, aldehyde is oxidized to carboxylic acid. Let's look at the example below. Pentanol is oxidized to pentanoic acid. Next, let's look at the oxidation of a secondary alcohol. If we remove the hydrogen on the carbon and the hydrogen on the oxygen, a pi bond forms between the hydrogen and the carbon, giving us a ketone. The example is as follows. Isopropyl alcohol to acetone. Lastly, we are looking at the oxidation of tertiary alcohol. The carbon that is bound to the hydroxy group is also attached to a tertiary carbon, which means there is no hydrogen attached to it. If we oxidize a tertiary alcohol, there are no hydrogen to be removed, hence no reaction occurs.
In conclusion, there are two key terms on this topic, which are oxidation reaction and oxidizing agent. We must really know what is oxidation reaction and oxidizing agent to have a better understanding on this oxidation topic. Oxidation reaction is a chemical reaction in which oxygen is added to or hydrogen is removed from an element, molecule or a compound. Now, we know that oxidation is the loss of electron, the loss of hydrogen, and the gain of oxygen. Just remember this formula. Leo, loss, electron, oxidation. So, oxidation is always the loss of electrons. Then, we learn that oxidizing agent will gain electrons and loses oxygen. It is a substance that gains electron and loses oxygen, oxidizes others but reduces itself. We also have learned that there are strong and mild oxidizing agents. For example, potassium permanganate is a strong oxidizing agent while silver oxide is a mild oxidizing agent. Lastly, we have learned about the oxidation of different types of compounds. For alcohol, the oxidation of primary alcohol can produce aldehyde or carboxylic acid. Then, the oxidation of secondary alcohols will produce ketone, but oxidation of tertiary alcohols will show no reaction. Meanwhile, for aldehyde will easily oxidize to carboxylic acid. Now, let's make some practice. Complete the following reaction by filling in any missing product. First, cyclopentene react with dilobasic KMNO4 under cold. So the answer is 1,2-diol cyclopentene because the double bond will break and will substitute OH. The reaction name is dihydroxylation of alkene. Question 2. Benzyl alcohol react with PCC. So the answer is benzaldehyde. OH will remove, then it will substitute with double bond O and H to form aldehyde. Primary alcohol use PCC will stop only at aldehyde. PCC is weak oxidizing agent. So the reaction name is oxidation of alcohol. Last question. Methylene cyclohexane react with hot basic KMNO4. So the answer is cyclohexanone and CO2. The CH2 will remove and then substitute with O to form carbonyl compound. So the reaction name is oxidative cleavage of alkene.